Hey guys, today we are going to do another Centroid example problem. We're going to be doing problem number 5 from Centroid Practice number 1. Problem number 5 is the same problem as problem number 4, but we're using a method called the subtractive method here. So let's go ahead and take a look at this problem. So we've got the Tetris block, and this time we're going to be using the subtractive method instead of the additive. So with the subtractive method, what we're doing is we are actually going to have our first shape, be this total 6" by 6" block. And this highlighted shape here is actually a negative area. So we'll still do the math the same way, but anything that's associated with the area of that shape is going to be negative. Alright, so let's calculate our areas. So I'm going to call this shape up here shape 1, and I'm going to call this overall shape shape 2, just like we did before. So area number 1 is going to be, it's got a base of 3 times a height of 2. We're going to give it an area of -6. Remember that it's negative because it's being cut out of the other shape. Area of the second block is going to be 6 times 6, which is 36. So if we take these two numbers and we calculate total area with them, 36 minus 6 is 30, which, by the way, is the same area that we got in the previous problem, which makes sense because it's the same shape, right? Okay, so let's go ahead and calculate our centroids. So x1, x2, y1, and y2. Alright, for our first shape, the x centroid is going to be 3 divided by 2, since it has a base of 3. So it's going to have a local coordinate of 1.5, and we'll convert that in just a second. Our second shape, the overall rectangle, is going to have 6 divided by 2, which is 3. The y coordinate for our first shape is going to be 2 divided by 2, which is 1. And we will have to convert that in a second as well, since it's not on the origin. And our overall shape is 6 divided by 2, which is 3. So our block over here is not on the origin. It's actually 3 units over from the origin. So our x-coordinate for our centroid, we're going to have to add 3 to it. So that means that the coordinate with respect to the origin is actually 4.5. In the same way, this block is located 4 units above the x-axis, and so our y-coordinate is going to have 4 added as well, so that it's with respect to the origin. So that means that our y-coordinate is actually 5. Alright, so let's take these numbers and put them into our table just like we did before. So our x1 and x2, x1 is 4.5, x2 is 3. Our y-coordinates, y1 is 5, y2 is 3. Now here's where we have to be careful, because a1 is -6. That negative sign is important. So I'm going to put that in the x and the y table. And then my a2 is +36. Alright, so just like before, we're going to multiply across and then add down. So 4.5 times -6 is -27. 3 times 36 is 108. 5 times -6 is -30. 3 times 36 is 108. So I've multiplied across. Now I'm going to add down. So -27 plus 108 is 81. And -30 plus 108 is 78. Now, if you just watched the other video, or if you already have done problem number 4, then you may notice at this point that these numbers are exactly the same as the numbers for the previous problem for sigma xi ai and sigma yi ai. So spoiler alert, we're going to get the same answer. All right, but let's plug it in anyway. So our x coordinate is going to be sigma xi times ai divided by sigma ai. Plugging in those numbers, my sigma xi ai up here is 81. My total area, sigma ai, is 30, which is 2.7. My y-coordinate is going to be sigma yi times ai divided by sigma ai. Sigma yi times ai is 78. Total area is 30. So plugging that in, you get 2.6. So just like we got before, the coordinates for our centroid are 2.7 as our x and 2.6 as our y. So that's how you use the subtractive method. It's almost exactly the same. The only difference is that we use a negative area shape. And this can be a useful strategy if you have basic shapes and it's just a little bit quicker to have a shape that is being cut out instead of being added to it. So there might be circumstances where it's useful. Personally, I don't use this method very often. I often mostly use the additive method. So make sure that you continue to work on these problems. Remember that on Centroids calculation number 1, you have to complete problems 1 through number 9. If you need anything, feel free to reach out. I'll see you guys in the next one.